Quotient rule and negative exponents. These are going to be your notes from Mr. Tretna. This is Math 2 from Clovis High School. So, joke of the day. Did you hear about the man who stole a calendar? He got 12 months. Remember, as you're watching this video, to smash the like button. I learned that from giving a shout out to Lane in period 1. Okay, so as I do these problems here, you guys want to be taking active notes, which means that you want to be writing down whatever I write down, including even some of the stuff that's already typed in. Okay, so we're going to go over the quotient rule first. So the quotient rule, and the word quotient means that we're going to be dividing, and we're going to be dividing monomials. Okay, so whenever we're doing the quotient rule, there is going to be a division symbol involved. Okay, now remember, typically that symbol right there would indicate that there is division going on, but also if you see a fraction written, like let's say 3 over, I don't know, let's say 2, that line right there, the fraction line, also indicates division as well. So whenever you see a fraction line, that's going to be division. And the quotient rule is simply this. If you are dividing two expressions that have exponents, and the exponents in this example are m and n, and if the bases are the same, then what you do is, to simplify the problem, you leave the bases alone. So if the bases are both a, the simplified answer, the base is going to be a, and then you subtract the two exponents together. Okay, so an example involving, let's say we have a base of x with an exponent of 9, and I divide it by a base of x with an exponent of, let's say, 4. Okay, the quotient rule says that to simplify this answer, you leave whatever the bases are alone. So the bases are x, they will stay x, and then you subtract the two exponents. And then when you subtract, it's always the denominator exponent, which in this case is 4, subtracted from the numerator exponent. So x over x to the 9th power divided by or over x to the 4th power is going to simplify to x to the 5th power. Okay, and this rule applies the same no matter what the bases are. So if the bases are numbers instead of letters, so let's say that we have a base of 5 with an exponent of 8, and we're dividing it by a base of 5 with an exponent of, let's say, 2. To apply the quotient rule, you leave the bases alone, so the base will stay 5, and then you subtract the exponents. So 5 to the 8th power divided by 5 to the 2nd power would simplify into 5 to the 6th power. Okay, now if you have coefficients involved in front of the bases, so let's say you have a 12 and a y to the 4th power, and then you're dividing it by 3, so a coefficient of 3 with a base of y, and let's say that y does not have a power showing, although we've talked about this before. If there's no exponent showing, then that means the exponent is a 1, so you can put a 1 there, but you don't need to. Okay, so if this is the case, what you do is, the first step in the quotient rule, as you can see up here, is that you always divide the coefficients. So you would actually divide the 12 divided by 3. Okay, and that would give me 4. I got that 4. How did I get that? I went 12 divided by 3. So you actually divide the coefficients, and then the second step in the quotient rule is always you use the quotient rule by subtracting exponents of like bases. So I have a like base of y, and so I'm going to subtract the exponents 4 minus 1. So this would simplify into 4y to the 3rd power. Okay, doing a couple examples here, we're just going to go through and simplify these two expressions. So the first expression right here, notice I have a coefficient of 14, a base of x with an exponent of 2, a base of y with an exponent of 2, and I'm dividing it by a coefficient of 7 with a base of x and y. Okay, now these x and y's, they're not showing coefficients, so that means, or an exponent, so that means they have an exponent of 1. Okay, so when I'm simplifying this problem, the first thing that I'm going to do is I'm going to look at the coefficients and I actually divide those out. So 14 divided by 7 is 2, so I'm going to have a coefficient of 2 in my answer. So you actually divide out the coefficients, okay? And then I'm going to subtract the exponents of the like bases. Okay, so I have a base of x and I'm going to subtract the exponents, 2 minus 1. And then I'm going to do the same with the like bases of the y's. I'm going to subtract the exponents, 2 minus 1. So my final simplified expression would be 2x, and then 2 minus 1 is 1. I don't have to write a 1 power there. Y, and once again, 2 minus 1 is 1, so I don't have to write a 1 power. So that would simplify to 2xy. Okay, the next example, same idea here. We have more bases going on, more variables, so let's take a look at this. Okay, so to simplify this expression, remember step number 1 is you always actually divide out the coefficients. So I have a coefficient of negative 15. I'm going to divide it by a coefficient of negative 3. Negative 15 divided by negative 3, that gives me positive 5. Then I'm going to subtract the exponents of the like bases. So starting with the x's, those are like bases, I subtract the exponents, okay? 6 minus 5. Then I'm going to move over to the y's. I have like bases, so I'm going to subtract the exponents, 5 minus 3. Then I'm going to move over to the z. Now this z has no like base down on the denominator, so I have nothing to subtract, so the z will just be at the end of my expression. Writing this final expression out in simplified form, I would get 5x, 6 minus 5 is 1, y, 5 minus 3 is 2, so I get y to the second z. Okay? Now, if you end up with a final expression that has multiple variables in it, always get in the habit of writing out the variables in alphabetical order. Okay? All right. So now let's move on to negative exponents. Okay, so there is a rule in math that says that you can never have an answer that has negative exponents in your final answer. If you leave an answer that has negative exponents in the final answer, then that expression will always be considered incorrect. Okay, so there is a negative exponent rule, and the negative exponent rule says this, and if you were reading a math book for fun, like I do rather frequently, this is what the negative exponent would say. It's saying that if you have a base of a with a negative exponent of m, you rewrite that as 1 over a to the positive m. Okay? And the converse of that would be if you have a expression starting with a negative exponent of 1 over a to the negative n power, you would just rewrite that as a to the n power. Okay? So applying this with some numbers, so let's say I have an x to the negative 2 power. Applying the negative exponent rule, we would rewrite x to the negative 2 power as 1 over x to the positive 2 power. Okay? No negative exponents there. That's okay. So let's say I have a y to the negative 3 power. If I wanted to rewrite that with a positive exponent only, I would get 1 over y to the positive 3 power. Okay, if I start with a fraction that has a 1, and then let's say I have a z to the negative 6 power, so the negative power is in the denominator. To rewrite that, I would just basically move this z from the denominator up to the numerator. So I would have a z here. The negative 6 power would become a positive 6 power. And then really that part gets moved to the numerator and there's nothing below the denominator, so we don't have to write the fraction line there. So 1 over z to the negative 6 would simplify to just z to the positive 6 power. Okay, so we're going to use this idea, this rule of negative exponents, to simplify these next two expressions. So in this expression right here, I have 6x to the 8th power times negative 3x to the negative 7 power. So I have multiplication going on. So this would be an example of where I'm using the product rule. Now, remember, if you recall, the product rule said the first thing we do in the product rule is we actually multiply the coefficients. So we're going to take the 6, which is the coefficient for the 6x to the 8th. We're going to multiply it by the negative 3, which is the coefficient for the negative 3x to the negative 7. So that's going to give me negative 18. And then the product rule says you add the exponents that have like bases. So my two like bases are x, so then I'm going to add the 8 and the negative 7. Okay? So this would become negative 18x, and 8 plus negative 7 is positive 1. Now, you don't have to write that positive 1, so you would just write this answer as 18x. Okay? Now, if you look at your final simplified expression, if there are no negative exponents in your final simplified expression, then that means your answer is good. That is a perfectly legit answer. Okay? So as MC Hammer sang, that answer is too legit, so we can quit. You can go ahead and sing along, Donovan. That's good. You too, Jordan. Good. Prince, copy these notes down and stop writing in pink pen. Okay, the next problem that we're going to simplify, the next expression that we're going to simplify is this one right here. This would be an example of where we have to use the quotient rule. Okay, how do I know I have to use the quotient rule? Well, you use the quotient rule when you're dividing. So what's the first step in the quotient rule? You actually divide out the coefficients. So my first step is I'm going to take the 32. I'm going to divide it by the coefficient in the denominator, which is 8. So 32 divided by 8 is 4. And then the quotient rule says to subtract the exponents with like bases. So my first like bases are a, and then I'm going to subtract the exponent. So I'm going to take the 5, and then I'm going to subtract from it the negative 2. And then I'm going to do the same with the b's. I'm going to take the next like base, which is b, and then I'm going to subtract negative 3, and then from the negative 3 I'm going to subtract the x. Working that out, I get 4a, and now 5 minus negative 2, these two negatives next to each other make a positive. Yes, a negative and a negative always result in a positive. Okay, so that becomes a to the 7th power. And then it's going to be b, and then negative 3 minus 6 is negative 9. Okay, now that is your expression that you have ended up with. Now the question is, if you end up with an expression with a negative exponent in it, is that okay? The answer is no, that is not okay. If you leave your expression like this, it will never ever be marked as correct. So we have to apply the negative exponent rule in order to rewrite this problem so that we no longer have negative exponents. Okay, so when I rewrite this problem, everything that has a negative exponent associated with it, which in this case is just the b, I have to fix that. Okay, anything that does not have a negative exponent associated with it, which would be the a and the 4, I don't have to change at all. So the 4 and the a to the 7th power, I don't have to move to simplify, but the b to the negative 9, I would have to put down on the denominator, but then the negative 9, which is associated with the b, would become positive 9. So this expression would finally become 4a to the 7th power over b to the 9th power. Okay, that is it. You're going to get a worksheet and you're going to be applying these rules.